Hi, welcome to the Expert Unreal Training Center. I'm Dan and I'm the Education Coordinator here. Today we're going to learn how to build a power-up in Unreal Engine 5.6. So strap yourself in and let's get started.
So imagine your player's touching a glowing mushroom and instantly grows, just like Mario. Today, you'll build this iconic power-up using Blueprint visual scripting and collisions in a side-scroller project. By the end of this lesson, you'll be able to set up your player to detect when it touches an object using collision overlaps, make your player grow bigger when it touches that object through actor scaling, and understand and apply Blueprint inheritance for reusable game logic. You'll start with the provided side-scroller template, then add a glowing object. When your player overlaps it, your character will grow, just like in the classic platformers. This is a core game mechanic seen in many real games. Collisions trigger power-ups, damage, and other game events in almost every game. So being able to set up and use your collision overlaps lets you design meaningful mechanics without writing any code. Everything is visual and fast. So now, without further ado, let's get into the tutorial. Okay, so in Epic Games Launcher, let's go to Library. Let's launch Unreal 5.6. Select Games. Select Third Person. We can call it Power Up. Variant, select Side Scroller, and then click Create. Now, when you get into your map, you're going to be defaulted to the third person character. If that's what you see, go to Content Drawer, Content, Variant Side Scroller, and then you'll have your level side scrolling there. And you can just load your level like that. We are now set up for our side scrolling adventure. Let's press play, and there we go. We've got our side scrolling level. You can jump. And something that we do have is a double jump. So if you press space twice, you get a very generous boost in your jump there. So very floaty, but it gives us the idea, right? This is exactly what we need to get started. So fantastic building blocks. If you want to build a side scroller, we have it. We have what we need. Okay, so let's have a look at the collectibles, the pickups. As you can see, they are static mesh. They're a blueprint. We can open them up. And we can have a look at the scripting. Let's go to the viewport. We have a static mesh sphere. And we have a sphere collision. So when our player collides with this sphere, that executes our programming. Okay, so you may have noticed a few things. One is that we already have collectibles in this template. So since the functionality is already there, there's no need for us to go and program it from scratch. So what we're going to do is we are going to, in our variant side scroller folder, we're going to go to blueprints. We're going to go to items, and we're going to go to BP pickup. We're going to create a child blueprint class, and we're going to call it BP PowerUp. Okay, and then save that. Let's go into that blueprint. Let's change the material. It doesn't really matter what it is, to be honest, just something that differentiates it. You can turn it into anything you'd like. You can make it a pyramid if you want. In fact, for the sake of just being different, because we've got a lot of spheres, let's make it a pyramid. So let's compile that. There we go. Okay, now we want it to glow. So I think we want this to stand out in the level. So I think maybe we can attach a light to it. So let's do that. Just add a little point light in there. Let's make the light color sort of a bluish or a violet maybe. Cool. Let's just stick it in the game and just have a little look. Okay, so in our BP pickup, this is our parent class, and our BP power-up's the child class. So we've got our event actor begin overlap here. When the player overlaps with the collision sphere, we inform the game mode that the pickup has been collected via an interface and then delete self. So all the way at the end, we can see that, the destroy actor. The connection with the game mode is to tell us that the collectible has been collected and it'll update the score for us. So now what we want to do is, we don't want to have to recreate this to create a collision with our item for our ability. We can just use functionality that we have here. So to do that, we will create a function and we will call it apply pickup effect. I'm making it a little bit general just in case we have other pickups that we want to use. We might use the same type of functionality again for something else. For this one, it's our mushroom, or our item that's going to make us grow big. Okay, so we can just leave that for the minute. Let's go back to the event graph. Now let's call this function. We can do it. I think it's a good idea to do it after the interaction message has been sent. You could do it here as well, but I feel like it's a good idea for it to be here. Okay. So there you go. We'll neaten that up in a minute. I just want to keep an emphasis on the fact of this is what we've added here in the middle of the chain. Compile and save. We do want to test it. Even though we don't have any functionality yet, we do want to test that the message is actually working. So let's add a string to that as well. There we go. Apply pickup. So let's see when we collect the item, let's see if it gives us that message. Yes. Okay, good. So that part of it is working. The function is being recognized in our chain. Okay, so now what we need to do is we need to go and apply this function in our BP power-up. The way we can do that is we can go to functions in our BP power-up. So we've changed our blueprint. We click the override and we can write apply pickup effect. There it is. We select it and we've done the override, and now we can access it in this blueprint here, in this child blueprint. So the first thing we can do is we can cast to our player character. Now, the instinct, if you've used Unreal before, will be cast to third person character, but that is in fact not what our character is. Okay, so let's go to our content drawer and just check. So we want to be in variant side scroller. There's our level, blueprints, and you'll see BP side scrolling character. So that's what we're after. That's what we want to cast to. So let's find that. Cast to BP side scroll and should come up there. From object, let's get player character. If you don't see it, just type the whole thing. There we are. And from here, what we need to do is we need to reference our growing function. So right now we can just print string and say grow. Let's compile and save. We'll save all. And let's just see if we get that message. Good. Okay, so we know that that's working. That's really good. Great. So now that our connections are in place, let's create the function Since we're affecting the player character, let's put the effect on the player character and have it be triggered from the power up. Okay, so let's go and create our function. Open up your BP side-scrolling character. Add custom event. We'll call it grow. And then we want to set actor scale 3D. Let's just make it double the size. Let's compile and save. And then in our BP power up, let's replace the string with a call to our function. So since we've cast to the BP side-scrolling character, we should be able to access this. So if I type grow, you'll see under BP side-scrolling character, grow, and then connect up to the target, compile and save. And now let's test it. And great. We're growing. Wonderful. Now you might have noticed we're not going to be able to get under here with our bigger size. So just to deal with that for the minute, let's Control D on this. Let's make a little platform so we can jump up. Okay, now let's try. Collect the power up again. There we go. Bigger. Use the warp to get up. Yep, there we are. And then double jump again and we're up the top. There we go. Okay, so now that we've got our power up working, let's create an animation for it so it looks like we're actually transforming when we hit the power up. So let's go to our BP side-scrolling character. We're going to add a timeline. Let's call it growth cycle. Let's play from the start, and on the update, we will scale the character. Okay, let's go into the growth cycle by double clicking. Let's make a track. We'll make it a vector track so it matches up with our scale axis, our actor scale axis. You can see it there. Let's name the track growth track. There we go. And we'll just connect it up here before we forget. So there we go. So now the values that we put in the growth track are going to be transferred to our new scale 3D. In the growth track, we want the length of our animation to be just 1 second. It doesn't need to be too long for a transformation. Then let's right click and let's do add key and value to all curves. Let's set the time to 0 and the value to 1. Now notice that I clicked and dragged there. If I don't do that, I'm going to separate the axes. Can you see that? So we've got our X, Y, and Z axis for our vectors. We want to move them all together. So I'll just Command Z there, or Control Z. Click and drag. Time 0 and value 1 for the first axis. Okay, just zoom out if you can't see it. Right click and hold up. So we're starting from there, from 1. As you saw, we were scaling to 2. So we want to get ourselves, by the end of this cycle, we want to be at 2. So I'll just pull out a little bit more. You can see there. So we're going from here to here. But because we want the animation to be nice and interesting, we're going to make it a little bit topsy-turvy along the way. So let's do a couple of points. So I'm going to right click again and add key and value to all curves each time. Yep. And don't forget to click and drag, and we'll just move them around a bit. Okay. Let's do a few more. Let's do a few more. Okay. Let's go back to the event graph, check that everything's okay. It looks like it's okay. Let's test it in our level. Here we go. Cool. All right. That's looking quite a bit like a well-known power-up animation. Excellent. That's what we were going for. Now that that's working, we can add a sound to it. Let's right-click and we'll type play sound 2D. Because of the nature of this 2D side-scroller game, we're going to treat the sound just like a UI sound. It doesn't need to be spatial or 3D. It's just a simple sound telling us that the power up has happened. I've downloaded a power up sound here. It was just an MP3 off the internet. I recommend using WAV if you can. I downloaded it to my desktop. I clicked import, and it was as simple as that. And I selected that file. It's here now as a sound wave. I'm going to just click and drag this sound wave to the sound, and there it is there. And of course, I could locate it from the drop down as well if I chose. I don't want it to be too loud, so the volume multiplier will be set to just 0.3. Let's make sure that we connect our executive pins. Remember, it was from play from start. Compile and save, and let's test that sound now. Nice. So that works the way we wanted it to. Okay, so now that we have our grow ability all ready to go, we need to make sure that the game knows when we're grown and when we're not. So we're going to just create a Boolean. We're going to go to variables down here, press the plus, and we'll call this isGrown. We're going to drag it. We're going to set it to true when this custom event is called. So in order to do that, we're going to have to first check if it's actually true or false. So to do that, we'll pull up a branch. We're going to connect to that. We're going to get isGrown. If isGrown is false, not true, we'll set it to true. And then the rest of the sequence can play out. I'm going to press C to comment this. I'm going to write grow power up. Now, it would make sense that if we can grow, we also want to be able to shrink back down. Usually, the way we would negate a power up or demote the player is if we get hit by an enemy, if we take damage. Since we're not going quite that far today, we'll just set ourselves a little timer. And then after that time, the power up will fade and we'll shrink back down to normal size. To do that, we can just create another custom event, add custom event. Let's call this one shrink. And we can do very similar work. We just copy the code or the blueprints. Now this one's only going to work if grown is true. So if we're already big, hold Alt and click to disable the pin. We're going to set it to false at that point, so we're not grown anymore. We will play a different sound. We'll play a sort of a damage sound or a shrinking sound rather than a growing sound. And we will reverse. Okay, so let's switch the sound. Okay, so we just need to trigger this shrink function now, don't we? Maybe we can comment it as well. We can do that by making a delay. Let's say 5 seconds. Of course, you can make it whatever you want, but just so we can show it very quickly. And then let's call the shrink. There we go. Let's move this back a little bit so it's not hitting other things. There we go. All right. Compile and save. And let's see what happens. So there you have it. You have your power up and your power down, and you can set the conditions for which those events occur. Congratulations, you did it! You built a power up feature that makes your character grow in the side-scroller project. So what you've built here is clean, engine-friendly architecture. You used blueprint inheritance to reuse and extend the base behavior of the pickup blueprint. You implemented a virtual override pattern, which was our apply pickup effect, and that allowed us to create a completely new item without altering the shared logic. In any game, player-driven feedback is super important, and you demonstrated that with a timeline-based animation and a sound cue to give auditory feedback and visual feedback to the player. You safeguarded your system with booleans to prevent repeated effects, and you included a delay reset mechanism to cleanly reverse power-up effects. So in the beginning, we set out to create a power-up that would make the player grow bigger when they touched the object. But what we actually did was blueprint engineering. We used dry principles, central logic, no duplications, and we overrode logic safely with the override panel. We built modular and reusable systems. We controlled effect timing with timelines and managed gameplay states with variables and delays. And we also learned more about the engine, what set actor scale is, what play sound 2D is, and when to reference player pawn or character. We did use visual scripting throughout this tutorial, but Blueprint visual scripting is an extension of traditional C++ coding. C++ coding offers maximum performance and control, but it can be more time-consuming for iterating on gameplay features. Using the blueprints, we were able to rapidly prototype. These are fundamentals of game design, and thinking and designing this way is a good way to future-proof all your designs. Great job, you've built a real power-up. Next, let's try adding destructible objects with similar logic. Okay, let's wrap up with something fun. Let's try some physics-based destruction using the chaos system. We hinted earlier in the video that we would like to perhaps add some more to just growing in the level. Maybe we want to destroy some terrain, we want to be able to change up the level, and do some things to cause a little bit of chaos in our game. So this is a fantastic way. In 5.6, the chaos editor should be enabled, but if you have any issues, just go to Edit, Plugins, and Chaos, and just check that at least the chaos editor is checked, and you'll need to restart if it isn't. We're just going to touch the very surface of this today, and we're going to go further in depth in the next video. First, pick a static mesh in your level. You can do multiple, but we'll just do one for demonstration, so let's pick the cube. Once you've selected your cube, hit
hit Shift 6, and that'll take you into your fracture mode, and that's from the drop down here. We want to generate a new geometry collection. So let's click that and pick your path. We'll just save it in meshes. GC Physics Cube is fine here. Create the collection, and we can see that it's represented there. Let's click Uniform, and you can see that the fracture is represented in our mesh. And then let's select fracture. Okay, wonderful. Okay, let's get our player start over here. I'll just select this. I'll copy the location. Let's go to our player start. And then we can just paste the location. There it is. Okay, now before we play, let's check that physics are enabled on our mesh, so that we can just go simulate physics. Yes, that is checked as true, so we should be okay. Okay, we can get out of fracture mode. Let's save all. There we go. Let's close the outliner and the details panel. And let's give it a go. And there you go. When you collide with the cube, it breaks. When we ran into that object with enough force, it would break. But you'll notice that we were small when we did that. We want to only be able to break the objects when we're large, when we're in our powered up state. So we're going to have to do a little bit of work to create conditions so that that happens. This is where I turn it over to you. I want you to figure out ideas and ways that this could be achieved in the logic. So pause the video, write your ideas down, and once you've done that, we'll go through. Okay, so I hope you've written your ideas down. I think the key factor here is to be asking the right questions. So I've got some questions written here, and let's go through them. So the most obvious question is, how would you handle conditional destruction? From there, you have more questions. What event starts the logic? Now, we have a lot of the answers to these things already. How did we trigger things before? The answer is we used an overlap event. We detected when the player entered a defined area, and then we made something happen. How do we make sure it's the player that triggered it? How do we filter actors? We cast to the player character. What player-specific value should we check? Now we added a variable for this. That was the isGrown boolean on the player. What actually makes the object break? We didn't use a blueprint to destroy it directly, so what caused the destruction? What we did was we enabled damage from collision in the geometry collection settings. And that way, when we collided with the object, or the player collided with the object, it broke automatically. If we wanted to control that, we would use applied damage in Blueprint. And finally, where's the best place to put the logic that checks if the player is powered up and triggers destruction? So we've used the triggers in the blueprints before, but where should the logic live? The best place is in a trigger actor blueprint, like a custom BP destruction. This is the modular approach and considered best practice. In the blueprint, we would implement the checks, we'd have the overlap event, and we could cast that overlapping actor to the player character. Make sure only player-initiated interactions are considered. We would check our isGrown boolean, and if it was true, we'd destroy the target. Try a hand at this, and in the next video, we'll walk through this all together. Okay, well done, you've done it. You finished the video, you learned a whole bunch of new things, and you've expanded your game-making horizons. Next, let's see if you can build upon the functionality that we started here today. I think you'll be surprised with what you can come up with. I've been Dan, and I hope you enjoyed the video. See you next time.